Hello, everybody. This is Lloyd Noronha. I head the global marketing at Viptela, and I really want to thank all of you for joining this webinar. I see people called in from all parts of the world. This has been our largest registration yet, and I really want to thank everyone for joining in. Keeping with our past tradition, we are going to make this a short webinar. We'll be talking for about 20 or 25 minutes. And we'll be looking at your questions as we present and take on and answer some of those questions towards the end. So with that, I want to get started. As you know, this webinar is being recorded, and I'm joined with my co-presenter, David Klebanov, who's the Director of Technical Marketing at Viptela. So regarding this particular webinar, we've gotten themes of questions repeatedly from our customers on talking about our existing deployments and what learnings there are from that. So if we look at the Viptela product line, we have been shipping for the last 2 years. We launched our product in May of 2014, and we've been shipping for a little more than 2 years now. And in that time, we have deployed about 15,000 production sites across a wide range of verticals, mostly focused on the Fortune 500, the Fortune 2000 space. And we want to use this webinar to kind of talk about some of those verticals, the learnings from that, and focus on 2 or 3 of these verticals and specific case studies along those lines. So these deployments, when we look at these 15,000 production deployments, some characteristics of them are that they have been across the world, so in almost all continents in the world, in most, I think, exceeding about 20 to 30 countries right now. Yeah. And also, it's the deployment methodology has been different. In some cases, it's been direct, operated by in-house IT teams. In many other cases, it's been with our system integrator or managed services provider partners. We have about 10 or more really large, MSPs or SIs that are partners. Some of the public ones that you know of are Verizon and Singtel, but there are other significantly large ones as well, who we are working with. So the deployments in different verticals has been, if you can see the slide, it's been in retail, hospitality, financial, transportation, healthcare, manufacturing, government, technology, and more. Now, if you look at these deployment themes of these verticals, on the one hand, we have, the retail, banks, transportation, which are very franchise-like operations where each site looks like every other site, and it's essentially a cookie-cutter approach to deploying a network. In most of these cases, the biggest requirements of the business priorities that drive some of these decisions are grounded in operational expense and the capacity that they need for new applications on the network. On the other hand, we have companies in the healthcare and the hospitality space, which have, if you characterize these deployments, there are few large headquarter-like buildings which have very sophisticated operations in them, and then many satellite operations that are spanning all over the place, whether those are small clinics or whether they are small distribution centers or small retail centers spread across different geographies. So in this case, the network requires a lot of sophistication at those big locations, and then support for the satellite locations after that. If you look at the manufacturing companies and the other holding companies kind of pattern, the big requirements there are centralized IT operations where they're rolling out a WAN service not only to their multiple holding companies, but they also want the WAN to be completely separated across those holding companies, as well as they want to be able to support their business partners on the network. So there are multiple themes along these lines, and of course, when you go into government, you're looking at various sophisticated deployments, and security tends to be the largest discussion point of those deployments. So across the board, what we want to talk about is some of the case studies. We, of course, cannot talk about all 3. So today we'll be focusing on a couple, which is about 3, which is manufacturing, healthcare, and financials. and we'll be diving down deeper into what drove them, what were the specific applications that drove them to make the change, and once they decided to make the change, how did they go about it? And as with previous webinars, we're going to jump directly into it, and we'll take any of your questions as you have them. So please use your chat window and your Q&A window, and I want to turn it over at this point to David. David, you want to take it away?
Yeah, sure. Thank you very much, Lloyd. So as you mentioned, there's pretty much deployments that span across every possible vertical. They have different careabouts, and in this specific webinar, we decided to really focus on just the three of them. And when we're talking about those three, the way that we wanted to position that is to give you a glimpse into what is the main driver that was the trigger for the organization to look more significantly into technology such as SD-WAN. Of course, SD-WAN comes with a variety of advantages, but there's always a handful of triggers that really take that company, that organization over the edge, so to speak, to really pull the trigger and look at that and go for deploying that. And that's exactly what we wanted to look at, to give you concrete examples for what was that trigger for those organizations. So the first one, let's look at the financial. It's a 1,500 site bank. So the ask that they were after was a rollout of a high bandwidth video application across 1,500 sites. Now, the target for the rollout of the application was to increase the revenue for the line of business responsible for that application by $1 billion. So it's a very strong business driver behind deploying an SD-WAN technology. And as that organization sort of looked around and evaluated different SD-WAN solutions and eventually deployed Viptela SD-WAN, there's a few things that Viptela SD-WAN solution was able to provide to them that made the task of deploying that high bandwidth video application an easier one to carry out. So the first thing that allowed that, and I'm really going to just touch on three main points that allowed that video application to be successfully deployed to reach the business target that bank was going after. So the first one was, since this is a high bandwidth application, high bandwidth video application, is relying solely on the MPLS network, which was the primary means of transport for that bank, was something that was not sufficient. So Viptela offered more capacity, more bandwidth capacity that was used in active-active fashion, somewhere by replacing MPLS circuits with two broadband circuits, somewhere augmenting MPLS circuit with an additional broadband circuit. So it's a variety of the means to deliver capacity in active-active fashion to allow the sufficient bandwidth for that video application to be rolled out. Now, when the application is rolling out, then of course there's a consideration for providing an adequate quality of service for the application, especially that this is a high bandwidth and high quality application. You want to make sure that after you have gone through the expense of procuring the infrastructure, you want to make sure that your video application quality is more than is adequate for your use case. And in that case, Viptela offered two main differentiators in the form of an application-aware routing, which is the ability to intelligently reroute around a brownout, a path brownout conditions, and make sure that should any of the circuits or anywhere on the path between the two locations within that bank experience any degradation of service, otherwise known as a brownout, then an application-aware routing functionality would kick in and make sure that the traffic is rerouted over the circuits that do not experience any degraded service. And they were able to set the specific SLA characteristics for that application of interest to make sure that the system always goes and abides by those SLA definitions. The second one from the application awareness is the application-aware topology, is to make sure that not only is the application forwarded across the best performing path, but it's also forwarded across the shortest path. So the combination of the shortest path and the best performing path gives you the utmost flexibility to deploy a high-quality application. And by the application-aware topology, I mean the ability to deploy simultaneously over the single virtual fabric, an ability to deploy a hub-and-spoke, full mesh topology or regional mesh topology. So the ability to influence the path that the traffic takes, coupled with the application-aware routing to reroute around brownout conditions. Both of those deliver the adequate service. And at the end of the day, being a bank, security is top of mind. So the ability to ubiquitously encrypt across all the transports, and I'm not just talking about encryption in the form of just doing IPsec, but actually intelligent system for being rolled out across 1,500 sites, which is really not an easy task to achieve through a traditional point-to-point IPsec means. So this is where Viptela brought the intelligence of the SD-WAN solution and decoupling of control plane and data plane into that environment that allowed the system to easily scale to 1,500 sites. And as that bank continues to grow and add more locations where that high bandwidth video application is deployed, it's an ability to just continue growing your network as your needs grow. So this is about the financial customer. The next one is the 400-site manufacturer. So what were the triggers for that company to look at the SD-WAN adoption? The triggers for them were primarily around segmentation of different lines of business at scale. And when we're talking about segmentation, we're really talking about dozens of virtual segments that are deployed over single unified virtual fabric. So the ability to do the line of business segmentation at scale was an imperative trigger for that organization to explore an SD-WAN technology. And at the same time, the manufacturer had business relationships with numerous partners that had to be accommodated as far as having access into the manufacturing floor or the systems that manufacturer operated. So the ability to securely bring the partner connectivity into the environment was also top of mind. So what are the three things that Viptela enabled for that customer? So as I mentioned, a single virtual fabric to be able to deliver that highly segmented environment for lines of business while diversifying the last mile technology. So as those line of businesses spread around the world, the last mile technology is not something that can be set in stone. So the decisions are taken on a side-by-side basis as far as what is the most optimal last mile technology that should be utilized for that site. And that could be a broadband DSL or cable, or in some cases in the rural areas, it could also be the 4G or 3G cellular technologies to provide connectivity into the fabric. So it's a single virtual fabric with diversified last mile, and the end-to-end segmentation is really allowed to compartmentalize those line of business and to make sure that there's a clear segmentation between them, and running, as I mentioned, dozens of those line of businesses across a single virtualized fabric. Now, for the partner access, that could get a little bit tricky. Is that you want to get you want to provide business partners access, or technology partners access into the system. And those could be just resource planning systems or just a manufacturing floor environment. Yet at the same time, you want to make sure that it's done in a controlled fashion. In this case, Viptela was able to provide an extranet service to be able to bring the customer into the virtualized environment while keeping the boundary between the segments that the partners were brought in and the rest of the segments that were for the purpose of line of business use, that those were segmented through a stateful inspection such as firewalls or intrusion detection, intrusion prevention means.
And just to add to what David said, if you look at the before-after picture in this network, before Viptela deployed the SD-WAN, the manufacturer had about 18 VRFs in their network on a single MPLS link and another 18 VRFs on a backup link. And they had no segmentation really for their business partner network. So it was a very a security risky network in that sense. So risk-prone network in that sense. So along those lines, after the transition, they were able to move to 18 or more VRFs across a hybrid network. So it was a network consisting of MPLS and broadband, and they could maintain their 18 VRFs, but the VRFs were on the SD-WAN network and not on the MPLS network. So it was much easier to deploy and manage those VRFs because the same segmentation was being maintained across MPLS, broadband, and in some cases the LTE links they had on the network as well. In addition to that, they were able to roll out a large number of VRFs for their segments for their business partners and keep each of them completely isolated from each other. And as you know, in manufacturing, the protection needed for each of the business partners, because each of them is working on a secret product which they are not ready to launch yet, etc., is highly critical. So these aspects were very important for a manufacturer.
Yeah, that's a very good point, Lloyd, is really the ability to deliver a transport-independent fabric across any set of transports, MPLS, broadband, 4G LTE, point-to-point links. The ability to deliver that fabric and to be able to segment that traffic was an extremely important thing. Before, that manufacturer basically used the services provided by the service provider. So, of course, segmentation is not something that was created just for that project. It, of course, it's a technology that could have been deployed before, but it required a cooperation from the service provider. It was also very much bound to a specific type of technology. So, of course, technologies such as an MPLS provide significant means of segmentation into the private VPNs. But first, it had to be negotiated with the service provider to make sure that the traffic is mapped to the proper VPN. And second, that approach was only applicable to an MPLS network. As that manufacturer looked to diversify the last mile connectivity and start employing additional means of to get people basically connected to the fabric, the ability to segment while using, let's say, broadband last mile is possible, yet it's very operationally cumbersome. So the immediate advantage that manufacturer drew from the deployment is the ability to highly segment their network for either line of business or the business partner access without the reliance on characteristics of a specific transport such as an MPLS and diversify last mile. So the last one that we wanted to touch upon is the healthcare. So the biggest trigger, or the most significant trigger for the healthcare provider, was the ability to deploy a highly available and highly resilient network. And just to kind of ponder on that for a second, when we're talking about high availability and high resiliency, we mostly define things in a matter of uptime. Is it 3 nines? Is it 5 nines? And it's really measuring the minutes that is acceptable for the network to be down. So if you're thinking about a healthcare provider environments such as operating rooms, surgery rooms, things of that nature, we're really talking about a life-critical environment where the high availability and resiliency of the environment takes a completely different shape. So we're not measuring a downtime in a matter of minutes, but we're literally measuring downtimes in lives that could be impacted if during the surgery there is a delay or inaccessibility to critical patient data, for example, or maybe collecting a reading for a specific sort of function from a monitor. So network characteristics as far as high availability and resiliency come in a very significant light when you're talking about a critical healthcare provider systems. And in this case, what we were able to deliver to support those high availability and resiliency environment in a life critical environment is to make sure that the system is highly resilient with no single point of failure in any single element of the system, and that extends from the device level, the circuit level, the path level, the entire fabric level, the control plane redundancy, and really taking that no single point of failure approach to every single element across thousands of hospitals and clinics that healthcare provider operates. So that's definitely an extreme top of mind. At the same time, as I mentioned earlier, some types of traffic that are being sent across the network it is not sufficient for just the network to be up all the time, or to be able to quickly recover from a brownout conditions. But it's also very important to prioritize specific types of traffic that could be leveraged during sort of a life-critical situation where doctors are trying to access that information, and to make sure that access is done in the most efficient and expedited way. For that, we had to offer a pretty extensive set of quality of service prioritization mechanisms across the entire solution, from a device level to circuit level to path level to an entire fabric level, to make sure that that traffic of interest, the one that is used in those life-critical environments, is always given the most preferential treatment, and make sure that healthcare provider enjoys the benefits of that. So as you can see, we kind of talked about three different case studies or mini case studies in this short webinar. Of course, we're short on time, so we can't just dive into all the intricacies of that. And you're more than welcome to reach out to us and to get more details. But as you can see, and as Lloyd has mentioned in the beginning, it's different environments with different requirements and a different approach that was taken for each one of them. And that's really the power of diversity, and to be able to accommodate all of those environments, which made Viptela a natural choice for those organizations.
Thank you, David. And if I were to bring David's examples together in one picture, this would be that picture which really talks about the entire area of focus of SD-WAN, the set of challenges that SD-WAN is tackling right now. Whether that's something related to adding cost-effective bandwidth, whether it's related to security, either in terms of encryption, authentication, segmentation, and the likes, or if it's related to cloud readiness, or simply dropping complex operations complexity, right? To give you an example, one of the retailers that have deployed our solution was able to do a 1,000 device upgrade in an overnight operation, a software upgrade on 1,000 devices. Now, comparing it from the previous mode of operation, where it would take easily 3 to 4 months to implement something similar, we were able to do it in an overnight fashion without any outages. Now, those are the kind of value propositions we are seeing across SD-WAN. Those are the kind of reasons why the customers are approaching us for this kind of solution. What we didn't cover today was something that was very obvious, but we didn't find time to cover, and that is, how do we maintain the current set of priorities when we make that transition? So, for example, when you look at a bank, we only covered the fact of how we're going to roll out this new video application. But what is, of course, table stakes is, how do we maintain the criticality of all the existing applications? How do we interface with the existing routers, with the existing MPLS or traditional deployments as we are making the migration? And after the migration, what kind of policies ensure that the critical applications are up and running in a manner that's either equal to or better than it was before. Because that is, without solving that piece of the problem, we do not have a conversation to begin with. So we didn't spend time on that today, but rest assured, those are the kind of things we have to address to even attempt to solve the problem, especially in the Fortune 500, the Fortune 2000 league of companies.
Yeah.
So with that, I want to say that we're going to continue our tradition of focusing our webinars on actual deployments and actual user stories, and also bringing more of our partners into these discussions so we can talk about some of our joint deployments. So in the next 30 days, we're going to do a webinar with Verizon where we will talk about, again, our success stories across multiple verticals. We're working together with Verizon. And also how we have operationalized something as new as SD-WAN in the period of months, when a typical time for a carrier to operationalize new technology is typically in the 9 to 18 months time frame. We were able to do it in about 3 to 6 months, and even before operationalizing it, we were able to onboard a whole bunch of customers. So we're going to talk about those stories with Verizon. With Zscaler, the story is going to be completely around how two independent solutions are really completely changing the architecture and customer network. So as you know, Zscaler takes care of all the layer 4 to 7 security. It provides its entire solution in the cloud, and Viptela completely handles the transport connection pieces of the customer network. So if we look at network and security, how are the two solutions completely integrated today? We have joint policies that can actually integrate and deploy into a customer network today, and we have multiple deployments in extremely large environments, and that's what we're going to talk about in our joint webinar with Zscaler in a month's time. Look out for that email. I'll be sending it soon. And with that, I want to turn it over to you for some questions. I know we've gone a couple of minutes over, so if you have any questions, I'd like to take it up. I see a few coming up. So
sure.
The first one's for you, David.
Yeah.
So on the segmentation, the question of segmentation with regards to the manufacturer, how is Viptela able to maintain segmentation across the multiple transports in the network, or is the segmentation restricted to only some transports?
Yes, right. So the segmentation approach is built upon the foundational principle of our solution, which is abstraction. So the first thing that Viptela technology does is it abstracts an existing transport, so we can abstract a specific and unique characteristics of those transports and elevate those into an entire fabric level. So the segmentation is something that is available in an MPLS network and has been available in the MPLS network for the past decade and a half. We are abstracting the segmentation, and we are making the segmentation available to the types of transport, such as broadband or 4G LTE, that segmentation is not inherently built into those. It could be deployed through an IPsec VPNs running separately over those transports, but the transports themselves have no characteristics of segmentation. So what we're doing, we're stepping away from segmentation principles that are bound to specific technology and elevating that into an entire fabric level. So as you deploy diverse transports, you are able to configure basically policies through Viptela vManage system, which is a single pane of glass for all the management, operational troubleshooting tasks that you can perform on Viptela Fabric. So through the vManage policies, you can define segmentation rules that would allow you to segment your traffic irrespective of which one of the transports that traffic is sent across. And again, in case of the manufacturer, that's how they were able to accommodate dozens of virtual segments in a completely isolated fashion across a diverse set of transports. Now, the communication between the segments, you may want to allow the communication between the segments in a sort of controlled fashion. So you don't want sometimes you want the isolation to just be maintained and be sort of complete isolation. Sometimes you want to make sure that the isolation is only partial, so you want to make sure that one segment is able to go to the other segment, yet pass through a stateful inspection device. And we have a couple of ways we can accommodate that, either through our extranet methodology or some other means. So that's a deeper topic that we can dive in. If somebody has a specific interest about segmentation and how we can accommodate segmentation within the network, or segmentation for M&As, or segmentation for business partner connectivity, we would love to. If you reach out to us, we will talk more details how that's possible. It's not an easy test to achieve because there are some sort of complications that are required by especially interacting with existing environment, with existing brownfields. But it's absolutely something that we've been doing for quite some time now.
Yep. So the next question is around security and concerns around security. So to read the question, trading out MPLS private circuits for broadband DIA circuits changes the attack surface.
Yeah.
SD-WAN devices do not provide best of breed from a firewall perspective.
Yep.
So what is being done to improve Viptela's firewall capabilities, something that's similar to Checkpoint? So essentially, how do we handle security?
Yeah, it's a good. So security is very, very fundamental to our solution. It's an excellent question. Thank you for the question. Security is something which we hold very dear. It's basically across the entire stack of our solution. We employ several methodologies within our product that would make sure that you are not increasing an attack surface on your environment, even when you are connecting directly into broadband circuits without placing any firewalls in front of us. In fact, we do not advocate placing a firewall in front of the VH router when it connects directly to the broadband or 4G LTE circuits, which are non-private circuits. Now, why are we so bullish about this, right? So the way that we designed our product, the product is employing a zero trust philosophy. The zero trust philosophy means is that everything is denied. Basically, nothing is allowed to communicate to the device unless it's been the device basically, or every element of the system. It's not just the VH routers themselves, but the same philosophy applies to the controllers and the management system. Is that the system is trusting nobody to begin with. So when you put it in, turn on the power and plug in the circuit, those elements deny everything, every single piece of traffic that is targeted at them. And now, as they start the bring-up process, and as they start discovering the rest of the infrastructure element, they start allowing the responses to the requests that they're sending out to be allowed inside to reach the device. So as the VH router, for example, discovers its controllers and discovers its management system, it's going to dynamically allow the return traffic from those elements to come back to the VH router. So VH router, if you're trying to launch a denial of service attack against that device from an unauthorized source, that basically will be prevented, right? There's no way that you can do that. The traffic that is destined to the control plane of the device, if somebody's trying to flood the device with control plane traffic, we have mechanisms for control plane policing that would prevent that traffic from reaching the device control plane and compromising the integrity of the device. So there's, it's not a checkpoint firewall, as you have mentioned, but the devices provide a security for making sure that the device itself is secure when it's connecting to an unsecure transport. Now, after the devices have been brought up, you can of course deploy a multitude of security policies, such as blocking traffic, allowing traffic based on application signature with deep packet inspection, or just based on 5-6 tuple matching. So those are all policy level decisions for the traffic that goes over the secure tunnels, over the secure fabric. But the fabric itself is zero trust All of the elements are trusted. Everything, every conversation within the two devices in a system is security, is certificate authenticated and predicated on a mutual trust between the devices through the certificate trust. So it's a very, very significant thought that has gone through to make sure that the denial of service attacks against the infrastructure itself are mitigated, that the trust that is established is secure. So quite a lot of hoops into that.
Yes, and also to complete the checkpoint angle into this, for anything that's internet bound, you know, that we either support existing security devices. We directly interface into those devices, whether that's Zscaler or Palo Alto network devices. And we have the ability to set centralized policy on our engine to direct the right traffic to those devices. So, for example, you can set a certain set of, you know, social media traffic to go through, for example, an IPS IDS engine, a firewall engine, a UTM engine before it you know, either goes in and out, before it goes in and out of the network. And you can set all those policies centrally and then monitor it on the central dashboard of your security provider, which could be Zscaler or others. Moving on to the next question, has your segmentation solution been independently tested to prove it is robust?
Yeah, absolutely. Yeah, I see quite a lot of interest in security and segmentation in here. But yes, we take great pride in doing pen testing for our features and for our technology. So segmentation is definitely one of those things that we subject to the pen testing. It's been proven and deployed in quite a few environments now.
Yes, and also you know, it's also for example, it's also the mechanism in which we achieve PCI compliance. So when we're talking about banks, retailers that want to isolate regulated portions of their network, they achieve that using segmentation. So if it's POS transactions of a retailer or you know, any financial transactions within a bank, isolate it using segmentation, and these have been tested by them and by independent parties, and we are compliant.
Right.
The next question is related. Let me just pull this up here. The next question is, how does Viptela achieve topology awareness if we are transport agnostic?
Right. So Viptela solution, and it's actually related to the segmentation. As I think about, if you have your virtual fabric, and if you're able to segment your virtual fabric into multiple sort of virtual segments, what Viptela solution does is that allows you to deploy through policies that are configured in our main in a vManage system, allows you to deploy different topologies, making sure that each one of the segments that you have created can have its own topology. So when you create a segment that would carry, for example, your unified communications traffic, and you want that unified communications traffic to be isolated, and at the same time you want that to be following a full mesh, because you know that you're going to have people doing voice and video calls from site to site. So you may want to have that segment operate as a full mesh environment. At the same time, you can have a traffic which is, let's say, has compliance requirements. So that traffic, you may want to swing it through either a main data center for firewall inspection or a regional data center where the firewall service can be inserted for that traffic to be inspected. So for that segment, for that VPN, if you want to think about that this way, you can deploy either hub and spoke or regional mesh, or regional hub and spoke or regional mesh topology. So think about taking your environment, which is even though it's virtualized across any transport, it's still a single fabric, and allowing you to carve VPNs in that environment, and those VPNs can be used for either purposes of isolation, or those VPNs can be used for the purposes of establishing a topology which is friendly to an application that you're trying to run on top of this topology. And again, you want to make sure that things like application-aware routing will make sure that the traffic is for that application is rerouted around brownouts. But to make sure, but when you have multiple topologies for application-aware topology, then you make sure that not only is it best performing, but it's also the shortest path, or maybe the path that is compliant with what you're trying to do. So the application awareness and segmentation are many times walk together.
Yeah. The next question, and this is the last question we'll answer, what are some of the challenges, if any, you experienced during the rollout of the 3 scenarios? So this is a very good question. I alluded to some of these challenges earlier when I was talking about the bank deployment. And those challenges were the fact that in that particular case, we had to move from a dual MPLS network to MPLS broadband plus LTE and ensure that during that transition, all the existing application SLAs were being met. And in addition to that, we had to introduce new applications into the same environment. So a lot of that testing was related to making sure that, ensuring the challenges. The challenges were essentially how do the policies map correctly from the old to the new. And oddly enough, we've done this many times over, migrating from traditional environments. So we are able to essentially templatize most of these things and don't face a concern there. On another area, I think the big challenge we face is the diversity of deployment. There is no cookie cutter approach to this from a deployment perspective unless it's in the same vertical. For example, multicast is a big requirement for manufacturing verticals, and they are globally distributed, and they have sophisticated policy requirements across the segments, etc. Whereas in healthcare, the requirements are more around how do you not replace the existing network, but how do you augment the network? So in retail and banks, we're directly replacing existing networks. In healthcare, the risk averseness is so high that they want to be able to augment for some time, see that it works, and then make the transition. So that's the challenge we face on the healthcare side. So the challenge really is to make sure that everything completely interoperates with existing Cisco, HP, and other devices in the network while the transition happens. The other elements of transitions are all, very characteristic to deployment. So in case of retailers that move from MPLS to all broadband, the initial challenge is how will VoIP traffic be handled. The concern is mainly around latency. Again, in those cases, we make sure that when people are concerned about the SLA of some applications, we keep MPLS and broadband up for some time. We build the overlay over both, and using our dashboard, you can actually see end-to-end latencies of each and every circuit in your network. For example, we currently have a deployment which is global with multiple sites in Shanghai and Hong Kong, talking to the U.S., and the latency when we looked at the dashboard yesterday was 210 milliseconds for broadband and 200 milliseconds for MPLS. But unless the customer sees something like that, they are not willing to take the leap of faith that VoIP traffic and other interactive traffic which was going on MPLS can go on broadband. So in those cases, we have to make sure there's a migration interim step. So those are a few challenges. I'm happy to dive more into challenges for each of those verticals. If you send me an email at lloyd@viptela.com. So sure. With that, I think we have the end of our time. We wanted to wrap up by 9:40. It's about 9:45 here locally. I really want to thank you for attending this webinar, and I look forward to having you in the future webinars. Please register for the Zscaler webinar. We'll be sending out that email soon, and the Verizon webinar you can register from our site directly. Thank you so much. Bye.
Thank you very much.